up, I think.
Yeah, you uploaded it yesterday.
Yeah.
Really? Yeah. Wait, I thought we did 4.3 on Monday.
4.3 isn't part of what we do.
4.3 is not on the...
Oh, 4.5. I'm sorry.
Oh,
Yeah, 4.5.
all right.
Extra credit.
4.2 is it.
Better? Thank you. All right, guys. I think we feel a little better. It was so barren in here a couple minutes ago. I'm like, damn, what happened?
Everybody? Yeah.
All right, guys. So I have a question from 4.1.
Yeah.
Which one?
Number 39. And the reason I ask, Professor, is because I got 0 equals 0.
What number?
And no solution. 39. 4.1. Because I didn't know if 0.0 was feasible. So.
It is 0 equals 0.
Oh, it is.
It's the same damn line.
Oh, okay. And I guess I would just needed to understand why.
So you went to that on some
So 0 equals 0, you're basically just...
All right, guys. Guys. People. All right, cool. So where the hell are you when you got here? You won't. So there's a question. Now, answer me this: if the answer to a system of equations is always a what? Where's the answer to a system of equations?
Point.
That's a point. What three things could happen then? There could be a point where they meet, or
And if the number of points.
they could meet everywhere,
Or they could be nowhere.
or they could meet nowhere. Right? Parallel, same line,
Or
different slopes. You guys got that?
Yeah.
So, algebraically, what the hell happens in each of those situations? Well, if there is no solution, we know what that should look like. I should get something like 0 equals 1. And if there's an infinite number of solutions, we know what that should look like. That should
0
look
equals
like
0.
0 equals 0. Right? You just got to be careful. You can't say all real numbers anymore because you just told me the answer is supposed to be points. So all real numbers makes no sense. So when you do this one, it says to do this using substitution. So how can I use substitution to solve
Multiply
this?
first equation by 2.
move the y over.
Yeah, I would take number 1.
And
Guys,
Oh yeah, that's right. Add the y to first equation, add the y to the other side.
sure, you could add the y over, subtract the 5. Is that cool?
Yeah.
Solve that first one for y.
Now that's
I
a more
skipped a couple steps, but you could do it. And now what can I do with that?
that's a more comfortable looking graph equation.
substitute that right into number 2.
I don't want to graph it. It said to use substitution.
So go
Plug it right in.
minus 2, 4x minus 2, then put in parentheses,
Exactly.
2x minus 5.
4x minus twice y, but what's y? It's this.
Yeah, so that goes into the equation.
Which page?
Page
Page 307. Yes.
Section 4.1. All right, so when you distribute this, you get
4x minus 20 equals
4x minus 4x
minus
plus-
20. Oh, minus 10.
plus
Plus
10.
10.
Equals
And what do the x's do?
10. They
Cancel.
So you get 10 equals 10. You can stop right there because what do you know now?
It's
How
the
many
same.
answers are there?
Infinite.
Infinite, good. And how do you say it? What's the
All
answer?
points on line.
All the points on this line. Because they basically wrote the same line twice. How'd they get number 2 from number 1? They just
Multiplied it by 2.
doubled it, right? So it's the same line. They just told me the same thing twice.
Yeah, okay.
So that's what this is trying to tell me. Algebraically, I'm going to get a weird answer because they started with a weird situation. They're not two different lines. It's the same damn line. They lie on top of each other. So algebraically, I know when I get a weird answer, it's either 0 equals 3 or something. So they don't even meet anywhere. There's no solution. Or it's this, where I get an always true statement. Now don't just circle that and keep going. That's a, ground shaking. 10 equals 10. Write a paper on that. Put it in there. I've discovered that 10 equals 10. You got to give me the answer. And like you said, all points on the line. Because again, the answer is where they meet. If they meet everywhere, then all those points are the answers. Cool. Is that okay?
And number 42, if you don't.
Oh, that's gonna be the same situation.
Oh, it is again?
All right,
Oh, okay.
yeah.
Page 3, 4, 5, number 6.
What section?
Number 6.
Oh, yeah, so I forgot that, so.
Is that section
Section
4.5?
4.5. Let me see. I need to go through here and pluck out all the ones. Since I made section 4, what was it, 2, I made section 4.2 extra credit. So if you guys weren't here last time, you might want to take note of that fact. Section 4.2 is extra credit. In section 4.5, there are a few problems that have 3 variables in them,
Yeah.
like number 6. So problems like number 6 are obviously going to be part of that whole section 4.2 extra credit business, right? So if you hit a problem in 4.5 that requires 3 variables, that's related to 4.2, which is extra credit. So it'd be a little evil for me to expect you to do it now when I made the other section extra credit. Is everybody with me? So let me see. Number 6 was every third one, right? I think there was too many here that were 3.
Number 6, 3 one like also.
Okay.
Small, medium, large.
Let me see. 28 and 27 both have 3 unknowns. 27 through 30 it looks like. Okay. So just be careful. In 4.5, if it needs 3 variables, that's that section that I made extra credit. So if you don't want to do that section 4.2, you don't need to do the 3 variable problems, right? Like number 6. So how can you tell if it's a 3 variable problem? Well, look at 27. It says a collection of nickels, dimes, and quarters. Okay, there's 3 things. That's going to be 3 variables, right? Okay. All right. Is everybody cool with that? Okay.
They will do one for us.
What's that?
You will solve it for us?
No, I already showed you that, and it's extra credit.
You will not do it?
No, I will not. So if you want help with extra credit, you can always come see me.
And number 12, okay.
So number 12 I can do, yeah. So 12 says a woman earns $1,350 in interest from 2 accounts in a year. She has 3 times as much invested at 7% as she does at 6%. So in this section, there's a couple different ways to do this problem really, but this section is really all about multiple variables, right? So how much does she have at 7%? I don't know.
X.
X, and how much does she have at 6%? Y. I love it. Now they give me 2 relationships between these. One of them is easy. She has 3 times as much at 7% as she does at 6%. So this one is how related to that one?
3Y.
Careful. This one is 3 times as much as this one.
3 1.
So X is 3 times Y. She has 3 times as much here as she does here. So she has more in this one. This one is 3 times as much as that one. What's the other relationship? That's the one that's a little bit more difficult. It has to do with this, the money part, right?
Yes.
How much money does she make from the 7% account?
X
Give you a lot
plus
of footroom.
times X.
Because how do you do it when you put money into an account? How do you tell how much money you're going to make? You put $500 in there at the end of the year, it's going to be 7% of the $500 you put in there. Well, how much money did she put in there? X. So how much interest does she make from this 0.07x?
So X is going to be the amount of, is going to be the interest at the end of the year.
No, X is how much she put at 7%.
Oh, okay.
Yeah.
Never mind.
So how much interest did she make? 7% of that. How much interest did she make from this one?
6% of that.
Yeah, so plus the 6% in this one, of course, has to make 1350. Cool.
What is A plus at the beginning?
That's the.
At. At.
Sorry.
I normally make my T automatically like that, because you're right, it looks like a plus otherwise.
For the council, at sign.
Okay, yeah, exactly. Cool. I seem to be in a impatient mood today, so just watch out. What do I do here? What is this beautifully set up for?
Multiply by, substitution.
Yeah, x is 3y. So here I can put 3y, and then I can solve this equation. So that's as far as I'll let you guys finish that one out. That's not a big deal now. Once you get these set up, it should be easy. And this is nice. X is 3y. Sweet. Substitution. Weirdest things happen outside the door. Like Zena put it by. Is that right?
Just to substitute it.
Yeah, that's what I would do. All right. Anything else? Any other question? Yeah.
Set up number 15.
Good. Now this is the one I was expecting question.
4.5?
Same section, yeah.
Okay.
5. I can take this away.
No, come back.
So read through 15. See if you get the basic idea here. All right, now I've got kind of a, anyway, I've got an interesting example of this. So let's say you're making, well, let's see, I don't care. Say you're making chocolate milk. I was going to say rum and Coke, but let's just use this. Let's say you're making chocolate milk.
That works too,
and
you know.
It's too chocolate. There's just too much chocolate in that thing. I'm not sure how that can happen, but let's say you just don't like that much chocolate. What would you do? You just add a little milk in there to dilute the percentage of chocolate, right? Same thing with rum and Coke, really. But so how many gallons of 20% and 50% so you get 30? It makes sense. If I put 20% into 50%, I'm going to dilute it.
You're going to take 30% of it away.
Right? In fact, some of you guys might, if I got a 20% alcohol solution and a 50% alcohol solution, and I want to add them so that I end up with 30%. If I had equal amounts of each,
They go to
I want
0,
you to
right?
see this. If I had equal amounts of each, and I added them together, what would the final percentage be?
Nothing.
No.
Or not. Oh. 50-50, so half and half.
This one.
What's right in the middle of those?
35.
35. So think about it. Does it make sense? If I add equal amounts of 20% and 50%, won't they kind of average each other out then? So if I had equal amounts of each, I'd end up with 35%. I want you to see how this is really, that's a physical thing, not a mathematical thing. Right? If I had...
Weird.
No, it's not. I really want you to see this. If I had water and I was going to add it to 100%
Scotch.
acid or whatever.
Oh, you could have
Right.
did Scotch too. That would have worked.
Yeah. If I put equal amounts in, won't it be 50% now?
50% of each, yeah.
Yeah. Well, 50% period. 50% acid now, right? Same idea here. It's going to meet in the middle, isn't it? So
The less amount's going to go away,
I
right?
really want you guys to see the physical aspect of this, if each the same amount. So if I want 30%, not 35, but 30, which one do I want more of? The lower one, to bring it down lower. Do you have to do any of that to do this problem? No, but it's good to know ahead of time that I expect this to be more than this. So if I get 7 of this and 3 of that, I did something wrong. And if you don't understand the physical thing behind this, you would never know to look for that, right?
Yeah.
So I want you guys to realize this is not purely mathematical exercise, playing with the numbers, you know, this is real life.
Chemistry stuff. Right?
Yeah, chemistry stuff. So what do we got here? What are our unknowns?
20% become related to X.
So what is X exactly? X is the amount of 20%.
Percent, yeah. And Y for 50%.
All right, beautiful. Y is the amount of 50%.